Good morning, everyone. I'm Lily. This is my teammate Yujing. We are the students from Hong Kong University. Today we will introduce our project, Human Voice Analyze and Virtual Teacher for Speech Series of Children with Speech Sound Disorders. At the beginning, our preview is these 4 parts. Now I will introduce the background about this project. SSD is the most prevalent of childhood communication difficulties. Considering more than 70% of predatory speech language pathology cancer, the success of the speech highly relies on the effectiveness of long-term home training. Because of this, we face home training to design our project. According to 5 series principle of SSD children, we design our project. The first is to intervene early, because infancy is the key period for children's structural development of the nervous system. Second is to set a proper intervene target. In the SSD intervene, it will focus on different aspects, like children's basic social need and language ability. In our project, we will focus on children's phonetics spirits. The third is we need to consider children's various characteristics. For example, in the intervening environment and teaching method influence the children. The fourth is the practicability of the intervening methods. The method should consider the things that children learning can use in daily life. Our project provides children with practical language class. It will include Cantonese daily use language and etc. The final one is repeat stimulation. With the help of repeat stimulation, children can find the regulation in the progress. It is also the most efficient way to improve language ability. Our class is repeatable. Children can watch it everywhere and every day. In this progress, we want to give high-risk SSD Cantonese children an early intervention in a convenient and efficient way. This is our project objective. After children diagnosed, we will focus on their voice spirit. The virtual teacher will teach the children. In the platform, different courses are offered and all of them are repeatable. Now we are in the first stage of our project. We will divide it into 2 parts, face and voice. For the voice analysis, we will compare the accurate pronunciation with the children and compare whether their pronunciation is wrong. For the face parts, we will use the 3D model to create a virtual teacher to guide and teach children. In the second stage, we will combine the 2 parts. We want to realize the virtual teacher which can enable to do the pronunciation and mouth movement correction. So this is our work. We designed a virtual teacher to correct the children's pronunciation and mouth shape and provide Cantonese pronunciation lessons for children. So at the beginning of design the virtual teacher, we have 2 different choices of model images. One is cartoon images like the Doraemon, and another is the real images like this. Considering about the facial attractiveness, the cartoon images have stronger facial attractiveness than the real images, so we choose the cartoon images as an image for a virtual teacher. We first attempt to create a 2D model. We use the Live 2D software to do it. This picture is the 2D model we create and it blending the face elements. But we found that the 2D model cannot clearly show the mouth movement, so we changed to make a 3D model. This is the software we use to make a 3D model. Blender is an open source software and it can support all 3D model creation programs. And Audio 2-Face is a dedicated software provided by NVIDIA. It can specialize in completing speech to high precision expression animation. So this is the final version we make a virtual teacher. Firstly, we use the Blender to create a 3D model. Then we will use the Audio 2-Face to simulate voice and face animation. Currently, we have made a beta version for face in Blender and will remake the cartoon model later. In addition, we achieve primary lip shape and voice matching with Audio 2-Face. This is our current progress. So Next, Lingjing will introduce the voice parts.
So now let me introduce human voice analysis. Our main aim is to judge and correct the pronunciation of young children. First, we record and analyze whether their pronunciation is standard, and if it's not, we intervene the SSDs through mouth teaching and standard voice to help them correct their pronunciation. My part is mainly to analyze and process every voice to achieve our goals. The main tools we use in the project were Slab and Audacity. Slab is an open source software for data analysis and computation. It is also an alternative to MATLAB. Slab is known as a science lab and is a problem related to digital data. On this software, sound can be visualized and can form the quantifiable spectrogram. But MATLAB is also a good choice. It can design and implement speech synchronization and processing software, and also design digital filters for filtering process. However, compared with MATLAB, Slab is more suitable for solving low-level scientific calculations, and we are more familiar with the use of it, so we choose Slab for sound analysis and processing. Our work mainly divided into 5 processes. First one is building a library of standard Cantonese syllables. Second, analytical sound library. Third, recording children voices. Fifth, analyze the children pronunciation. And last, compare it with a library of analyzed sounds. The first one, second one is mainly to establish our sound database, and process 354 is meant to start at runtime. Next, I will cover my main points in detail. These 2 images are 2 forms of the sound of the word will. The one above is the waveform diagram, and the below is spectral diagram. This is the phonetic transcription of the word will. As you can see, will is made up of 3 syllables. In the picture above, each syllable is marked with the different color. The following diagram is the spectral diagram. The 3 syllables in will, U, E, and L, form their own fixed waveforms, and all the way together form the complete spectrum for the word. I'm going to show you the information of the word in detail in the next slide. For the waveform chart, it is difficult to judge the pronunciation of the syllable and whether the pronunciation is standard, while the spectral chart can determine whether the pronunciation of children is standard through many conditions. Therefore, we convert the cover image into spectrogram and then the sounds into a quantifiable form. So I'm going to show you 2 examples of our test. We know that will is made up of 3 syllables, U, E, L. The 3 graphs below are the symptogram of the 3 syllables. The frequency value of the picture is horizontal axis, and the amplitude is the vertical axis. The amplitude of the above several sign signal is drawn on their corresponding frequency, and the amplitude and frequency distribution diagram of the signal is made. That is the so-called spectral diagram. Each syllable has its own fixed pattern, but as the tone and the volume change, the peak of the word form will change, but another syllable will not. We can clearly see that the spectrogram of the word will is formed by combining the spectrogram of the 3 syllables below. Therefore, we can find out whether children's pronunciation is standard by comparison and which syllables are wrong. Next, we investigate the pronunciation of the toddler who mispronounced the U as an S, pronouncing it seal. We can see that resulting spectral diagram is different from will on the previous page. Here is the EL sound. For ease of observation, I have adjusted the variable of this picture to be different, but we can still see that the mispronounced the U sound through this test. It can be seen that it is flexible to compare the spectrogram to find the pronunciation errors of young children. And this picture is an acronym of Cantonese syllables, almost very visual, and birth mother can form the character. And each word is seen as a combination of several syllables. And this is the process for us to build a database. First, we will analyze the consonant and the vowel one by one from the spectrogram we just talked about. Second, set up a database structure inside the audio spectrogram to form our own independent database. It is still difficult for us to build a database, and all we can do right now is analyze the audio and transform the data form. And this is the detailed process of our sound analysis. First, we record the sound using Audacity in the form of waveform graph, then export it as a wave file and use Select to call the audio analysis as a spectrogram. In the workflow, we mentioned at the beginning Step 2, analytical sound library, and Step 4, analyze the children's pronunciation, can be solved using this method. However, in the future, we hope that second recording and analysis can be carried out at the same time to improve the efficiency of sound analysis and help users to give feedback faster and achieve better intervention effects. Finally, our project focuses on analyzing human voices and creating a virtual teacher. In combination with virtual teacher and voice analysis, we can provide early intervention for children at high risk of SSD. And at present, we have made a virtual teacher model and the basic process of sound analysis, and create a batch of spectral graph data which can teach SSD students Cantonese 9.6 sound and record children's voice to compare with the standard pronunciation. That's also difficult in combining virtual teacher and voice. In the future, since we are now only dealing with web feature, we plan to develop software function to form a set of self-development technology to realize the soil states, create children online learning platform. Right now, we can only analyze sound, so we hope that we can allow your children to get feedback, which can overcome the weakness of the particular job. There are still some problem and difficulties in our research, and we plan to do it as soon as possible, improve this method, and realize the comparison of carrot mouse and round mouse. And this is our reference. Thank you for listening.